Okay, so today we are going to be talking about types of functions. So there are three types of functions. The one that you are probably most familiar with is linear. And then there is quadratic. And exponential. So this entire unit is how to identify these three different types of functions. So there are four different scenarios that you are going to be given. And depending on which scenario, you're going to have to tell if it is linear, quadratic, or exponential. So the first way that you're going to have to be able to tell if it is linear, quadratic, or exponential is by a graph. So a graph of a linear equation, which is kind of given to you in the name of it. So linear meaning line. So this needs to be a straight line. Then for quadratics, it will be in the shape of a U, or it could also be upside down, kind of like an N. Then exponential, it curves kind of like the quadratic where it's a U, but it never crosses the x-axis. So it curves, but it's not a U, and it doesn't cross the x-axis. Okay. So the next one is a table. The next way to be able to tell if it's linear, quadratic, or exponential is by a table. So for linear, you are going to have a constant pattern in both the x's and the y's. Meaning that, so here I am adding 1 every time to my x's. And for the y's, I'm adding 2 each time. So there's a constant pattern. And that's for both x and y. And hopefully you should remember this a little bit from last year, but that is called your slope. Then for a quadratic, your y values are going to mirror each other. So meaning that you are going to have this point that is in the middle, but then after that, these should be the same. Okay, and then for exponential, so your y values are going to increase quickly, but they are also going to multiply. So as you see here, 2 times 2 is 4, and 4 times 2 is 8. So y values increase quickly or have a multiplication pattern. Okay, the next way that you're going to be asked to figure out if it's linear, quadratic, or exponential is by an equation. So for linear, you are probably, should again be familiar with this, but that is the y equals mx plus b equation. But you could just have y equals x, or you could have like y equals 3x, or you could just have like y equals b, so y equals 5. So all of those are examples. So for quadratic, our equation is y equals ax squared plus bx plus c. So the big one here is that it must have an x squared. So if it doesn't have an x squared, then it is not considered quadratic. So that's the difference between the linear and the quadratic equation, is that this one is squared and linear is not. And then for exponential, it is y equals b to the x power. So this time your exponent is x, which is why this is called exponential. So the exponent is an x. But make sure that it's in the exponent spot and there's just not an x like the linear equation will have. Okay, and last way that they are going to ask you to identify these is in a word problem. So for a word problem, for linear, the word per, which is referring to the slope, is in the problem. Okay? Or there's going to be a word that is like the word per, so a synonym of per. Okay? Quadratic. They usually are going to talk about some sort of object or a person that goes up and then comes back down. So, an object must go up and down. Okay, and then for exponential, there is going to be a percent in the problem. So, like I said, we're going to give you either a graph, table, equation, or word problem, and you're going to have to tell us why it is linear, quadratic, or exponential, and why. So here are your explanations on why. And then you're also going to have to tell us why it's not the other two options. So you're going to have your counter examples to tell you why it is not the other ones. Okay? So now let's go ahead and go over our vocab. Okay. So our first word is function. So a function is any table, equation, or graph in which the x values do not repeat. So if you're looking at a table and or a graph and you see that it's going through the same x value 2 times, it is not a function. So a way to test that is the vertical line test. So the vertical line test is a vertical line that touches the graph at only one point ever. So if you were to put a vertical line anywhere on that graph, it would only touch the point or the line once and anywhere. So it might be only touch the graph once at one point, but if it touches a different the graph at a different spot twice, then it is not a function. So then there is function notation. Which is a way of identifying so it's an identification tool for functions that look like f of x, which means that it is interchangeable with y. So you can, an example would be you've got, like we've already talked about, y equals mx plus b. So it's just changing y into f of x equals mx plus b. So it's just a different way of writing an equation. Okay, I'm going to have to break this up into 2 videos because class is about to start. So I will see you in the next video.